Okay, I thought celebration. Just take that one. I don't want to make it.
All right, welcome everyone. We're gonna get started. Maybe one or two more people showing up, but want to be respectful of everyone's left out. So welcome to today's BSUG. My name is Dylan Agnes. I'm a research scientist at the Integrated Design Lab, University of Idaho. We focus on the outreach of high performance building design in the Intermountain West. This lecture today is sponsored by the Idaho Power Company. There's a couple of the other programs they sponsor for that. We have the Energy Resource Library, or the ERL. It's a free resource for Idaho Power customers. We have a collection of over 900 building diagnostic tools. So pretty much anything to do with power in a building, we have a way to monitor or track it and help give you feedback on its performance. You can sign up for a resource. You just need to create an account online with us. And then you can get going. We have it set up kind of like an Amazon web store. You just add to cart and you can check out. We do ask for information about the project that you're doing, your company, your business, things like that. We want to just keep track of that, make sure that our tools that we offer stay relevant. So any questions on that, let me know. We also have BSUG. This is the last one out of the year. We do 6 years during the beginning of half, during the second half. And so we will be having our stakeholders meeting either mid-November or mid-December. And that's kind of where we just ask people to show up, we bring food. We just kind of talk about the topics that we did for the year, what you thought of them, what you'd like to see going forward. Lastly, on a different note, we have our energy codes lecture this fall that we're doing. Here are the dates listed for them. You can sign up for the November 2nd one currently. And those will be offered in person and online. So make sure you use the appropriate registration link.
When are they? Are they during lunchtime?
That's a good question. Damon, did we decide on that?
They're in the morning. They're
in the morning.
Yeah. Wednesday mornings.
Yeah. Are we gonna have coffee? I feel like
We are gonna have coffee and
we will have coffee.
Yeah.
Next we have our technical design assistance. So this is based off of scope of work broken into 3 categories. It's less than 2,000 or 2 to 4,000. And those, you know, the less than 2,000 is you calling me up, asking me a question about a code or a software program or a standard daylighting feature, something like that. 2 to 4,000, we're doing basic simulation analysis, walk through kind of educating you or your firm on the project or basic recommendations and report. Anything greater than 4,000 gets put into a phase 3, and there's a cost share with 25% covered by the owner or you, and then 75% covered by Idaho Power. That has to be a detailed scope of work written up that has to be approved by Idaho Power. So if you're imagining it to be a bigger project, make sure you give us enough lead time.
Phases 1 and 2 are 3.
Yes, those ones we rotate in and out, no problem. And then Andy, did you want to speak on this or?
Yeah, I can speak really quick. So I'm Andy Morton. I'm with Idaho Power. And so like Dylan was saying, this is sponsored by Idaho Power. So just quick plug and information. We do have incentive programs for anything related to energy efficiency. So we have 2 prescriptive based programs, which is our new construction major renovations program and our retrofits program. For architects and engineers, we do have a professional assistance incentive. It doesn't take away from the customer's incentive at all, but you can get some incentive for helping them fill out that paperwork. So that's something that's really good to be aware of. If it doesn't fit any of those prescriptive incentives, then you can look into taking it through our custom projects program. So if it saves electrical energy, reach out and we're happy to work with you and see if we can get an incentive for the customer. Oh yeah, I always forget about this slide. Like I said, there is that professional assistance incentive. So that's the numbers on that 20% of the incentive that your customer is getting, up to $5,000 per project.
Okay, so now we're going to get into today's lecture. We're going to talk about CBECS 2018, the Commercial Building Energy Consumption Survey. So I'm going to look at this through a couple of different optical lenses. So we got the national typical CBECS trends. Then we have the data that they actually release, which is a much smaller sample size. And then we have what is specific to our climate region, the Idaho Power climate region, we're calling it. That would be climate region 1 and 2. You probably know it better as ASHRAE climate 5A, 5B, 6A, 6B. Okay. So CBECS. It's a national data on the characteristics and energy use of commercial buildings in America. This is one of the few databases that we have that is collective and you can easily make your way through it. A lot of other databases on building stock in America are all segregated or broken up or siloed off. So it's really important we have this survey. We've been doing it since 1979 periodically. Emphasis on periodically. There's not really a set schedule. It's kind of when Congress decides to allow enough funding for it to happen. I personally would like to see it happen. So since 79, we've done 11 of these surveys. So to get rid of the technical definitions, this is what is defined as commercial for the survey. So at least 50% of the floor space is used for commercial activities that are not residential, industrial, or agriculture. This might need to be reworked in the future for mixed use because we are getting more and more into that, especially in the urban environment. So it kind of breaks with depending on the typology of the building and how it's broken up. So building and structure closed by walls from foundation to roof for human access. It's pretty straightforward. I don't imagine that changing anytime soon. Building type determined by the principal building activity for the function that occupies the most floor space in a building. So this one again might need to be updated for mixed use depending on how it is. They have two separate categories, the principal building activity and then the principal building activity plus. So if you have an office, what type of office is it? But then again, if the office is 60% of it, but then 40% is residential or something along those lines, that kind of presents an issue for categorization. So why should you use CBECS? Forecast or project energy consumption. If you're doing, say, a 12,000 square foot office building, 3 to 4 stories, might be mixed use, might not. You can look and see what the average of the current industry is for that building type in your climate region. Okay, that's the big one. Set energy use targets for benchmarking. CBECS is really important when Energy Star was first getting off the ground because that was the database that we used for architectural reference to see how buildings were performing in relation to similar buildings. Fortunately, we've come far enough with Energy Star that we continually input data and build that database out that we don't rely heavily on CBECS as much anymore, but it's still nice for getting the overall big picture. Design policies and programs. CBECS is one of the ways we kind of take market assessment of how is the market responding to energy codes. Are they going in the direction we want? If so, are they moving fast enough? What policy changes might we make to get those desired outputs? Conduct academic research. That's a big one for me. Probably not so much for everyone else in the room, but it is great to be able to access this database, filter it, and ask questions and get relatively clear answers. Decisions. I don't know how prevalent this is, but it does cost money to operate a building to keep the lights on, and it's more than just keeping the lights on. So what is the average annual cost it will take you just to keep your building open? That is an expense that sometimes can be overlooked. So our process, what we did. So we took the CSV file that was released, we converted it to XLSX. That's a fancy way of saying just a typical Excel file type. That was so we could do formatting changes and save those going forward. Then we had to identify key changes from 2012 to 2018 in the microdata codebook. I like to call it the cookbook. That's basically a key or a legend for everything in the CBECS tables. And so some things were no longer asked, other things were asked, some things were recategorized. So we just had to identify those so we could keep the trends correlated. Next we did is we exported the data into 3 different files, general building use, information, and energy end use. Then we looked at the heating and cooling equipment, and then we also wanted to take a look at the lighting equipment and conservation features. Lighting is a new one for the 2018 that I added because I'm a daylighting lighting guy, so I wanted to put that in there. But so in the 2012 you won't see that for what we published, but it is on the 2018, and I hope to go back and look into that a little bit. So then we took those 3 files once they were organized, and then we put them together to create kind of a master splice file that we could then take and make a template for each of the building types we wanted to look at. So this research stems from a previous grant that the lab did before my time in 2013, 2014. And so I'm kind of just updating it for 2018, and then moving forward, I hope to do additional research. But so that is why we chose these categories. So initially, office, retail, education, lodging, food service, public assembly, public safety, and warehouse. They wanted to do all of these. Our CBECS is a pretty large database and takes quite a bit of time to work through. So they were only able to publish office, retail, education, and lodging. We are ahead of schedule. So we will have the first report published this year by the end of the year. And we'll start working on the next four for 2024 and the budget. But it is our plan to release the other four at 20. So that's the building types that we looked at, and here for each of the building types is the areas we wanted to.
Yeah, I was wondering, so on the building types, are you guys planning on doing any sort of cold storage, heavy industrial, or refrigerated, like food and beverage,
No.
or just?
This industrial agriculture is not included in that. That's kind of a sub category for it. So that information is not collected. But as far as like food service and food sales, that is a category.
Is that just like a restaurant or more like a cold storage distribution center?
It
Albertsons
depends. You
have-
gotta get into the data, because so this like food service, that's the overall one, and then it breaks down into the smaller categories as such. So
Are you explaining later what does the master file look like?
yes. Okay. So for each area, this is national versus climate region, national primary building application. So anytime you see CR, that means climate region. Okay, so that's what that means in the presentation. Looking at the fuel split between electric and natural gas, EUI by square footage, by construction date range. This one we had to change. So previously in the survey, they gave us everyone's building construction year. They changed that because of identity. They don't want you to be able to identify buildings easily, so to speak. So now they just give us ranges. So we had to change that into date ranges. By HVAC system type, so we have VAV, CAV, DOAS, and DCV. Economizer versus energy management system, renovations. And then new this year, daylighting and lighting system type and control strategies, and then EUI by building shape. So once data for each priority building type was analyzed, graphics were made to represent the data for ease of use. I know not everyone likes looking at tables or filtering Excel sheets. So graphics will be available to download by the end of the year on our website. And if you want, you can have the micro Excel sheet data that we use to create it. And then we basically rinse and repeat for each building. So let's get into that. So national versus climate region. So national refers to all census regions and all climate zones. So here's kind of how CBECS breaks it up. They determine these boundaries by looking at cooling and heating degree days and kind of determining, drawing the boundaries based off of those ranges. So we're going to be looking at 1 and 2. So that's primarily the blue and the green. And then, so this is kind of an important aspect of the survey that gets overlooked, is the building sample size. So some of the slides I'm using is directly from EIA, the Energy Information Administration. And so you notice it says 5.9 million number of buildings. You can't fit that many line types in Excel. Okay, it's just not possible. Once you get out of Excel, it kind of becomes a wild west for what people are able to read or write as far as data and coding goes. So the actual sample size that released to us is 6,436. Okay. But so the thing that we have EIA kind of trends, then we have the national sample trends, and then we're going to have our climate region trends. Okay. And so here's kind of what that looks up, broken up by building type. And so depending on the building size, it makes it a little more accurate and easier to parse through the data for margin of error and removing any outliers. So the sample size that we look at for climate region 1 and 2 is 1,850. the most prevalent of those building types would be office, education, warehouse, and public assembly. They make up 57.4%. And from there, we can go a little bit further and get into the census division. So we have a couple different census divisions in America. So the reason why we're going, even though this would be a really small sample size, we're going into this is to pull out specific buildings to have examples for the upper quartile, the minimum, and the lower, and just kind of examples. And so we're going to be using West and Mountain. And so that's going to be primarily Montana, Idaho, Wyoming, Nevada, Utah, Colorado, a little bit of northern Arizona, and New Mexico. And so that sample size looks like is 252. So very, very small, hard to draw, trends from a sample size that big. So we're just going to be pulling individual buildings. But if you're curious what that looks like, then it is available to you. Any questions on sample size or anything like that?
What is census regions? What are those?
Census region, so it would be West, and then the subgroup of that would be Pacific or Mountain.
These are geographic
Yeah.
regions?
The 5.9 billion, the total buildings available, correct, and then 6,000 is, or did they collect data on all?
So they collect building on 5.9 million buildings. They only give us 6,436 to work with. That make sense? It is a lot of space, a lot of computational power, and just very little know-how by the average person on how to parse through that data, how to organize it. Avoiding getting your computer to think itself to death. That's a big one when you get the data sets that large. So speaking of data, the larger the sample size, the more accurate the average values will be, but also helps identify outliers in the data set to provide smaller margins of errors. Okay, so keep that in mind. And so here's kind of what it looks like. We go each one. So the gold is the ones we are releasing this year. The semi-gold are the ones for next year, and white, well, we're not taking under consideration at this time. But you can see how office goes from 1329, 366 to 68. Okay. So this is what they release. At least part of the data they release is how they present it. And this is part of the reason why we developed this research, was to kind of help people through it, get a little more specific, and be able to address pointed questions. And so this is the basic CSV file that they give you. Very easy to navigate, right? Not dry at all. So like if you don't know like square footage, so SQFD, that's pretty straightforward. PBA, kind of have to know principal building activity, things like that. So the reason why we do it is because we turn it into this. So you have the variable ID. So if you want to, control F and look for it via the code cookbook, like to call it, or you can just go by variable name. Variable name is just a common phrase that we would use to describe something. So it's just a little more easier to navigate. So some of the national trends that we have, overall, we're consuming less energy per square foot of floor space from 2018 to 2012. Electricity and natural gas continue to be the main sources of energy use, with natural gas being the primary application for heating and electricity being the primary application for cooling. So that hasn't changed. However, large buildings, our buildings are getting significantly larger over time. And while they only make up 2% of our overall building stock, they account for a third of total energy consumed. So 2% of our building stock consuming 1/3 of our energy. So that's something to say that we definitely need to require more energy efficiency practices for larger buildings. Yeah. So no changes in energy consumption kind of really occurred from the last one. Other than electricity did go slightly down, natural gas went slightly up. But for the most part, we are kind of holding true. And while that may not be nice to hear, it is a relief when you look at the context for how much electricity has been increasing since the 90s. The fact that we are able to just, okay, stop using more. We need to figure out how to cap off and then reduce. So it's been a very nice change. And overall, you can see the trend. So while our electricity consumption overall goes up, our buildings are getting more efficient. Okay, so that goes back to the analogy of you will use more of a resource when you know how to efficiently use it. You will not conserve more. So that principle still holding true, but hopefully we can figure out a workaround. But for the most part, natural gas and electricity, as far as EUI, is going down. So, and then kind of here's that breakdown by building type. So you see it from 2012 to 2018. For the most part, we have done a good job at reducing consumption per building type. There are a few outliers like food sales, malls, things like that. But that I kind of equate to they have miscellaneous or miscellaneous energy use for displays, trying to convert to sales, things like that. They kind of view energy a little bit differently than rest of us. So major fuels by building type. So now we're going to kind of look at the national trend and the climate region trends. So major fuels intensity, this is EUI for different building types. So for here, what we're looking for is we want the orange to be smaller than the gold, and we want the blue to be smaller than the gray. Okay, so for the most part, we've done a pretty good job of that, of reducing it all, nationally speaking, as well as to our climate region specific. There are a few things that are trending upwards, but again, you would kind of expect that for those building types. And so looking at nationally, there were 3 categories that got called out for, that would be food sales, strip shopping centers, and other, where we did increase our EUI for major fuels.
You know, if in that other categories, is it such a significant jump? Is data centers included in that?
I'll have to look into that, but I do imagine the other categories going survey in 5 years, it would significantly increase just because of all the mixed use things that kind of get thrown into the other. I can look into it. I think data centers might have a subcategory under offices. Might. Don't quote me on that. But I'll get back to you. I'll email you when I look into that. So then looking at the climate region. So same thing, we have 4 areas where we did increase in our climate region. That would be food sales, refrigerated warehouse, strip shopping center, and other. So the refrigerated warehouse one was kind of an outlier for me. I didn't really expect that, considering a lot of the warehouses we are building now are more recently than when the survey was conducted. So I'd be really curious to see how that changes. And so nationally versus our climate region in 2012, you can kind of see the difference here. So if it is a negative number, then that we ended up using more energy in that category. If it's a positive number, then we improved. So you can see there's only a couple. And so that's where they are. So food sales, refrigerated warehouse, and food service. Yes.
So on the refrigerated warehouses, you know, a lot of those have started changing from ammonia to other refrigerants. Do you have any indication if that lower number could have been because of that?
No. And I say that because that's in 2012, and if we jump to 2018, the opposite happens. It gets more energy intensive. We use more energy. So I'm not entirely sure what that is. Warehouses have been on my to-do list to get into because how much we're building in the Treasure Valley recently. We did have a BSUG on high performance warehouses earlier this year. I might have to revisit that lecture to see if they talked about that.
At least directionally, that makes sense though, because ammonia tends to be a bit more efficient than like CO2 and some of the other systems that the refrigerant replaces.
The other plausible theory off the top of my head would be the size of the warehouses have increased as well as the use and frequency because they got more efficient. So we could be building them larger and more. So that could be why we have a.
But isn't this data in the intensity? So isn't it like a energy per square foot?
Yeah, yeah, there is. Get it. I don't have that on hand for the warehouses though. That's not one of the 4 we initially looked at this year. But yeah, I'm hoping to get funding to do that though. And so here's that, but this is probably a better slide to show that as a product report. So for 2012 to 2018, so we were 9 points behind, so to speak, but then 2018, we're about 2.79 points behind. So while yes, we are still behind the national average or national trends, we have improved. So there's only 4 categories where we went back. But overall, we are seeing improvement in how we use energy efficiently. Any questions on that? Okay. And so this kind of shows the other percentage of, you know, primarily it's electrical or natural gas that we're using, but we also have district heat and fuel oil. But overall, through the years, that has become minimal. We're not relying on it, we're not utilizing it as much, at least as far as commercial buildings are concerned. Okay. And so it wouldn't be an Idaho Power lecture if we didn't talk about electricity. So we're gonna get electricity by building type. Food service is the huge outlier that I need to take another look at because they increase substantially. But for the most part, we are, you know, stepping down until you get to certain categories. And overall, we're just consuming more electricity in our buildings. Primarily, in my opinion, that's due to plug loads. We just have far more devices everywhere and anywhere that need to be plugged in or require a connection to the internet, therefore require power to work and stuff. And so that's significantly increased. And so looking at the national from 2012 to 2018, nationally, we're doing pretty good as far as staying where we're at or coming down for EUI for electricity. But then for the climate region, specific to us, not so much. There's a lot of categories where we have definitely started consuming more. Food service being the most notable, but nursing, lodging, mall service, education, public assembly. Some of these make sense, like education, more computers, servers, things like that. In schools now, kids almost they have a tablet of some sort that they're using and whatnot. Other ones, not so much. So, you know, like lodging, I don't really understand how that got us such a significant increase. So there are some future questions we'll be digging into.
One question or observation is, could you also look at the natural gas usage to see if it's a result of electrification or not?
Are you a representative for Intermountain Gas? If you were, I would have an answer for you, but
I am a representative.
and I would be interested in pitching you a grant funding contract. So, not right now.
But when you look at food service and other, you may think that there is a big impact from electrification.
Yeah, and it could also be that through electrification. So yeah, those are just future questions we would like to answer. We may not know. Just trying to figure out the causality so that we can figure out the correct question to ask and investigate that. So yeah, we'll be looking into that.
Think of that information gathered as far as like if they looked at any changes to the buildings they
yeah, there are renovations categories specific, whether it was wall, envelope, lighting, HVAC equipment, things like that. And there are additional categories for fuel district heat, propane, natural gas, and the other one. There's one more. I'm sorry, I don't know off my head, but yeah, and you'll see that when like you get your hands on the micro Excel sheet, and you can start filtering and doing those things as well. Or I kind of hope to eventually get a system where you guys can submit an inquiry, and then we'll go through the database and give you an answer back. But we'll see. That's a long ways off. So nationally versus climate region, for 2012, we were doing pretty well. We were either at par or doing better. And then when we look at 2018, the opposite happened for a lot of spaces, our building types, sorry. Some of the ones that we are doing pretty well on are office or laboratory. Everything else kind of just definitely saw an increase in electricity by building types. So as I mentioned earlier, natural gas was used for space heating, and electricity is used most for cooling. That's pretty distinctly obvious that that's gonna be linked to your climate region or zone. But yeah. Any questions on any of that so far? Okay. So in addition to just knowing how much energy we're using, we wanna know how it's being allocated. So looking at electricity versus natural gas, you can see kind of a stark difference depending on the category. Office being the most notable of them using electricity to natural gas. Other ones can have a more balanced approach, but each one is fairly unique in how much it expends. And so we kind of wanted to look at that percentage based off of the sample size we were given. So looking at national versus climate region in 2012. Here we have the building types, percentage of electricity versus natural gas consumption. And so you can kind of see in some areas we're using more electricity, others we're not. And kind of all that correlates to how much does it cost. And so here's how much we're spending per building type in 2012 on electricity versus natural gas. And then if we look at 2018, here's kind of the comparison of the consumption. For the sample size, we kind of dropped out enclosed mall and inpatient healthcare. There either was no information or there was only a couple. So parsing through that data. But you can see some significant changes year to year from 2012 to 2018. And then most notably would be the cost. So overall, while we're using more energy for our climate region, we tend to be cheaper than nationally. That could have something to do with how we're producing our power and how we're distributing it. Other things that are like geographical unique to us, specifically in Idaho, Montana, Wyoming, geothermal. We have access to that more so than the rest of the nation. So things like that. Any question on gas versus electricity percentage or cost? And so here's kind of the comparison between 2012 and 2018 national and kind of the difference for energy use. So for here, if you see a negative, our energy consumption went up. And then if you see a negative for the cost, that means you're paying more. So for offices, we're using 5.12% more, and we're paying 23% more per square foot than we did. Out there, any questions? Any particular ones stand out to you guys?
But what did you-
When we're talking about comparing 2012 to 2018, the energy consumption, are there for like corresponding for the similar number of people or I'm just curious,
In this one, no, but in other data sets.
so
do,
is it
yes.
likely that in 2018 we have more buildings and this energy consumption are corresponding to more buildings?
It could be, in my opinion, it's more, we just have larger buildings. So we're just consuming more that way. And this also goes back to, I'm forgetting the name of the principle, but when you're more efficient and you have a finite amount of resource, you tend to go through it more quickly. So it could also be that where it's, you know, an example would be LEDs. Those are everywhere now. There are places where I never even thought we would need lights, but someone figured out a need for it. And so all that over time just adds up as we're getting more efficient. We're like, oh, we can do more with it. It's also one of the Goldilocks trends. So if you go to a high performance building and you do the typical set points and they get their utility bills back and it's really cheap, they're like, oh, well, we can afford to spend a little bit more on the energy. What actually makes me comfortable? Not what is energy efficient and economical, but what is my actual Goldilocks comfort temperature. And so you'll see it go down. That mindset goes up and it stays like that. And that's what they perfectly want that space or that building. And so I imagine it's something very similar where they realize, hey, we've reduced our operating costs by this much, we can now afford to do a, you know, et cetera.
Following up on Fernandez's question, the sample sizes between 2012 and 2018, were they about, were both about 6,000?
I don't know at the top of my head, but yes, it was very similar.
Just curious.
margin of error was negligible, I believe. I'll double check on that, get the actual number out. We should add that to the graphics. Hey Gregory, can you make a note to add that to the graphics, please? It's on mine. No, I don't have anything to write with right now.
Yeah. So
you.
how did some categories are consumed have lower cost per square foot in 2018 than 2012?
Just efficiency. Got more efficient and consuming and producing the electricity for the buildings, having the stricter energy codes and requirements.
But this is cost per square foot dollars. That's dollar.
Yes,
How is the dollar lower?
for which category specifically?
Laboratory, they're
Laboratory.
paying $2.05 per square foot in 2018 versus 2.2 in.
It could be just utility provider incentive, overall consumption of energy as far as electricity goes. Want to email me that question? I can look into it for you. I really only have answers on the 4 building types that.
So for the percentage that's in the first column, is that just percentage of
So for
electricity
office,
as energy?
57.32% is electrical consumption in 2012.
And the rest would be.
And then it's 60,
natural
and
gas?
it jumped up to 62.44%. And so the difference of that is we're consuming 5.12% more.
That's the fuel.
Fuel
use.
source.
That's the sort of-
Yeah, electricity.
Just making sure that's,
Yeah, I didn't break it down for fuel type.
no, that's,
We can, I can make one for you if you're interested in fuel type.
just making sure I do it right. Davis.
Yeah, so basically, offices are consuming 5.12% more electricity. And because of that, they're paying 23% or 23 cents more per square foot than we did.
That's not what you're saying there, because more percentage of overall fuel source, offices have gone down nationally. In terms of amount of electricity, that's just more percent is electricity than natural gas. So that doesn't mean it's 5% more. It means 5% more is electricity relative to natural gas effectively.
Yeah, that could be one way of looking at it. I would have to, I didn't dive that deep into the natural gas aspect of it. But yeah, so I understand what you're saying, is that from here,
57% of
yeah, so if we go, we pull out
electricity.
office, it's about 63%. That's nationally, and then nationally here, it's 57, 58.
So that just means it's shifted towards more natural gas, not that it's using more electricity, it's using less. If you look at the UI.
Okay, yeah, no, I'll do that. That would be a great graphic to have. And then basically same thing for the climate region, 2012 to 2018, kind of looking at that. So yeah, I'll definitely have to add a natural gas column to this and see how much of that percentage will contribute to that. Because I am interested for like specifically offices, how much is it is the transition or electrification of equipment versus just adding additional equipment and power loads to it. And then depending on the building type and size, it could also be renewable resources offsetting that as well. So there's quite a bit. Yeah, I definitely need to build this out a little bit more. Thank you for that. Any questions on 2018? Anything stand out to you guys that maybe I can hopefully clarify? Nope, okay. So then as far as spending, we spent 141 billion on energy in 2018. Overall average for $1.46 per square foot. So keep in mind that's not exactly apples to apples comparison, but nationally that's kind of the trend that we're going on, with electricity being the primary source of cost. And then how that breaks down, depending on building type, the categories that were looked at were space heating, cooling, ventilation, water heating, lighting, cooking, refrigeration, office equipment, computing, and other. So. Yeah, space heating continuing to be the primary load, and in some instances, depending on the building type, that's either lighting or cooking, kind of goes synonymous as taking number 2 or competing with number 1. So everything kind of fits the typical profile we would expect of a building type. It's just a matter of the intensity that we're operating it at.
That's an option.
Yes. Yeah, so anytime you see like the US CIA, that's the overall. One thing that I did really enjoy finding out was with lighting. We started tracking LEDs from 2012 to 2018. So LEDs went from 9% to 44%, which is just one of the biggest changes I think I've seen as far as trends. I personally would like to see incandescent not be a category and we just not use them. My personal preference. But pretty much everything, every other lighting type category for commercial building systems saw a reduction except LEDs. So the adoption of LEDs is well underway, and I imagine it will continue into the future. I'd be curious to see how long standard fluorescence holds the majority of the market share. So, and then some typical commercial building features or questions that were asked about HVAC was how do you maintain your HVAC? Going out there on an annual basis or biannual basis, programmable thermostats, building automation system, economizer, specifically pulling out VAV, DCV, internet connected smart thermostats. That's a pretty cool upcoming one. And then dedicated outdoor air system. And so you'll notice that is the percentage of total commercial buildings and then the floor space. And so the building automation system, yeah, we're not using it in a lot of our buildings, but we are clearly using it in our larger buildings, which we definitely should be. Same with economizer. So that's kind of what that means. And then again, because I'm a lighting guy, I wanted to look at lighting features and window features. We only had time to go through the lighting features, but so nationally, big picture, this is kind of how we're seeing the trends. Occupancy sensors, a lot of the lighting control strategies follow not a lot of buildings are using them, but all the bigger buildings are using them because the rate of return on investment for them is positive. So that's why we see them there. And we kind of had to force compliance with smaller building types, building size and building types through code, requiring them to do it. So now I want to get into graphics that we made. Show you guys that. Any questions? Would you guys want to look at education or office? We have time for probably at least one, maybe two. Any preference?
Office, yeah.
Office. Okay. Office it is. So. Not going how I thought it would go. That kind of works a little bit. So it used to be 2 11x7 or 1 11x17 front and back. Now it's 1.5. So 3 pages because we added the lighting category. So anything in red, we're still updating. But basically, and created by us, Idaho Power. But we have our national EUI, the sample size for the office building, and then our climate region EUI with the sample size. The first one gets into buildings with renovations. Keep in mind, this is a draft, so we're still editing. But so whether it was a mixed only or just specific lighting only, HVAC only, it's a little hard to parse them up because some would do lighting, some would do HVAC, and that was it, and whatnot. So we broke it down by, did you do a renovation? Did you not? And what's the category?
Since when? Since 2012 or ever?
Ever.
So just like not
Yeah,
original.
if there was a renovation. So 66% of buildings said yes, 28% no, 20% no, and then 5% unknown. I don't know how you don't know if you did a renovation or not. I feel like it'd be pretty prevalent. But we'd like to see that number be 100% because that means we are updating our building stock. We're not forgetting about the buildings. Typically, as far as energy analysis and auditing goes, we tend to leave to the wayside commercial buildings under 10,000 square feet because the cost benefit analysis isn't great, but it doesn't mean that we shouldn't be doing it. So I would like to see that increase more. And then so here's the activity breakdown. So this is the building principal activity plus. So this is office, but it's breakdown into government office, medical office, mixed use, other office, administration, or bank and financial. And then over here is where we're going to have some of our sample buildings, and then depending on information if it's available, calling out specific buildings that are notable in their categories. So if you know of one or your firm has one, let me know. I'll take a look at it. And then we have here breakdown by the category. Too much. But yeah, so 69.23, sample size 366, and then here's the key for how that correlates to the category. Okay. And then utility breakdown, we have the natural gas versus electric consumption, the cost percentage, total cost, and cost per square foot. So each one kind of going inward for the ring. Any questions on that so far? Okay. Next, we got the HVAC characteristics. So here we're looking at VAV, CAV, and DOAS. We kind of broke it down into, I believe this is called the Nightingale wind rose, if you want to look up information on that chart. But so it breaks it down by its building category, and VAV package individual EUI 67.35 versus district. Why is district on here twice? This is why it's a draft. I'm so sorry. Central. And so comparing those, I think this one is supposed to be other. Yeah, it's missing the other category. Don't quote me on that, but I'm pretty sure this is supposed to be other. And looking at CAV, constant air volume, DOAS, dedicated outdoor air system, and kind of just seeing those, comparing the package individual versus central versus district. We have tables on these guys with each one called out that you can kind of sort through and go do your own averages or ask your own questions. You can go in and filter and add additional columns, things like that. And then, so in 2012, heat pumps was kind of its own characteristic. And so we brought that data out, but it's a little bit harder to single it out because heat pumps are just so universal now. They don't really care about your HVAC system type. You can integrate them fairly easy with multiple system types. So it's available here as air source, ground, water, and other/hybrid. Other/hybrid means it wasn't there was a heat pump present, but it's not the primary application. If that makes sense. And then we have EMS, energy management system, and then economizers. So just breaking down, we didn't include heat pumps in here because again, it's just too much crossover. So looking at the system type and seeing if it is utilizing an EMS or if it is utilizing an economizer. And then we have building shape. So we broke down the energy use by building shape and then by the size of each building shape. And so you can see that plotted here. And then we have the EUI. And so the colors coordinate. So it's going to be a little bit hard for some of the colors, but they're supposed to coordinate. And then daylight area based off of building shape. Any questions on that? So we do have it by size as well. And if you want, you can go in and like if you want to know all the medical offices under 10,000 square feet, you can do that. You can ask that question. And it just requires a little bit of plotting with Excel afterwards. And so again, I hope to develop some kind of intake system where you guys can pose those questions and we can just produce it for you and kind of publish it, because I'm sure you're not the only one who has that question or will have that question, things like that. And then vintage or end use. So again, we had to change the categories on how we spread this up. So if you look at this one compared to our 2012 one, it's not going to make any sense. So we kind of have to redo our 2012 one with these boundaries. But these are the breakdowns. So before 1946, 46 to 69, 70 to 89, 90 to 12, 13 to 18. They did not explain how they did these cutoff dates. I'm not actually sure how they determined that. It might have something to do with the surveys when they were conducted. But I haven't read anything official on that. But sample size 401, giving you the EUI by category and kind of breaking it down, and then the overall UI for billing of that year type. Okay. And then lighting, so we have the number of lighting control strategies used. So well over 100 office buildings use no lighting control strategies. It's very depressing. And then the majority of them are using 1 to 2. As we get further along, it kind of falls off. And so those lighting control strategies could be setting up light schedules, occupancy sensors, multi-level or dimming, daylight harvesting, high-end trim, plug load control, and demand response. So yeah, demand response is probably the latest one that comes from lunar low lighting control. So I don't take that one with a grain of salt. It is very new. Very few buildings have that technology or utilizing it. Same kind of goes with plug load control. That is also not as new, but it's still relatively new. But light scheduling and occupancy sensors, those are the two main control strategies we see being used in offices. Primarily for the rate of return on investment, but also code now says you do not have a choice for the majority of spaces within those building types. Lighting systems, I just realized we need a key for that. Not everyone knows lighting. So FL being fluorescent, LED being LED, CFL compact fluorescent, IC incandescent, HID high intensity discharge, and HB halogen. Sorry, don't quote me on that. But so basically, lighting was given as a percentage of the building type. So if we have very few that were only fluorescent, only LED. Most lighting systems were hybrid. So we went off the percentage and the lighting type. So say a building was 50% fluorescent, 50% LED. They got categorized as fluorescent. As fluorescent is the older lighting technology, so it was probably renovated to LED, but not all of it. But if a building, say, was 40% fluorescent, 6% LED, categorized as LED, because that is the primary lighting system. Some of those is judgment call. We do have those in tables available for you to look at. Some of them are not accurate. Some of them, would list 4 lighting type categories, all at 50%. So it's kind of like, well, I don't know, maybe we'll remove that one. So there were a handful of the ones like that. And so depending on how you would make the final judgment would determine that. So go figure, lighting can't be quantified. So next we looked at daylighting. So we have the total square footage for our building type category, and we have the daylight area versus the non-daylight area. And then we look at all daylight harvesting. So 13.93% of this building type are daylight harvesting. Of the ones that do say they have daylit, so they say on the survey, they acknowledge they have daylit, only 13.11% of them use daylight harvesting. Everyone else, they have a daylight building and they just choose not to. So, and I do have to update this. I have fixed this number. I just haven't updated it for this. But yeah, any questions on any of the graphics? Anything overtly confusing you didn't really get, or because we're still developing these. So I think we've done a pretty good job at conveying the information visually. So I hope it will help. And yeah, so we have this one available, education, and we'll be getting retail and lodging as well. And then yeah, next year we'll be working on the other 4. Hopefully we get a good reception and people using this resource or asking us questions about this resource. That'll help us develop it further to suit your needs.
I guess you're running out of time. I have a question about your graphic.
Yeah, which one?
The numbers, could you help me understand the numbers relate to the last graphics about lighting? Yes.
Oh, I totally skipped this one. I'm so sorry. Is this one you have a question on? The one? No, okay. Up here?
For example, that graph is telling me 56% of the buildings are using. Okay, can you explain?
56 buildings have confirmed that their lighting system is only fluorescent. And then we have an additional 168 buildings that we categorize as fluorescent is the primary, but it is a hybrid lighting system. Does that make sense? Okay, definitely need I need a key for this, and we should probably explain that as a sum total whole.
So, our website where people find these.
Oh, yeah. Real quick though, for this is daylighting based off of, so there's 80 buildings in this category, 42 as far as the size goes, the square footage. Shows the total square footage, and then of that square footage, this percentage is daylit and this percentage is not daylit. And so we break that down by building size, so you can see the greater the building, the more chances of it actually utilizing daylight as a sustainable lighting source, as well as daylight harvesting to get a rate of return. So yeah, but then yes, to find these, they're not up yet. You can look at the older ones. Boise.com. And so under services, design tools. Will be added. I'll probably bump this down and add a new row here. But for like the last one, you can download them all as one single PDF. They're all together, or you can pull out individual PDFs and just click download. So yeah, it's that easy. You don't need to have an account or sign in. You can just download it. And then if we go back to the MicroMaster, so this would be where you just pick out the Excel sheet that you want if you so choose. We have other cool tools. Check them out. They're great. So these tools were kind of individually made, and then we kind of compiled them together. They're kind of a way to help remove reoccurring time barriers that might make energy efficiency or co-compliance or something like that a little more difficult. So just trying to make your job easier so that you get more energy efficient buildings. So yeah, any questions on that? Okay. If you have a particular question about a building type or something along those lines, you can send me an email. I'll get back to you. Hopefully be able to answer it, or at least provide data that direction. Okay. Thank you.